Today's lesson is all about a tangent to a circle and how to get the tangent's equation. Now there are a few things that you need before you can get to the tangent's equation. So let's start at what you have to do. We have to get the equation. For that we need the gradient. But we only have 1 point on the tangent, so we can't calculate the gradient only with 1 point. But we know from Euclidean that a radius is perpendicular on a tangent. Therefore, if you can get the radius gradient, you can tip and flip it and then use it for the tangent gradient. And you can use the point of contact as the y1 and the x1. In order to get the gradient of the radius, we need 2 points. So we use the point of contact and we need the center, the coordinates of the center. Right. So let's do some examples. The first example we're going to do is where the center is on the origin, and then we're going to do it where the circle is off the origin. Let's quickly go through the theory. A tangent touches a circle. If it goes through a circle, a line, then it's called a secant. And you also get a line outside of the circle. So if they give you these two pictures, you can't follow these steps because it's not tangents. Right. To get the radius perpendicular to the tangent, you need the center of the circle. Then you calculate the gradient of the radius. You use that to get the gradient of the tangent by tipping and flipping. Or you write radius gradient times the tangent gradient should be -1. And then you determine the equation. So these are the steps in order to get the equation of the tangent. Our first example, they say determine the equation of the tangent to the circle x squared plus y squared is 50. Now here I don't have brackets around the x and the y. Therefore, if the center of the circle is at the origin, always draw your picture. The contact point is -7, -1. Our first step says determine the center of the circle. Now we can conclude that the center is 0, 0 because of that formula. Then we calculate the radius gradient. So we use those two coordinates, substitute them, and you get the gradient of the radius. Now we have to tip and flip this gradient to get the gradient of the tangent. So the tangent is -7, and remember in analytical and Euclidean you always have to get your reasons. Don't forget your reasons. The reason is radius is perpendicular on a tangent, or the m of the radius times the m of the tangent is -1.
And if I write that formula of m radius times m tangent before, but I have to put it as a reason on the right.
You have to put it as a reason on the right. Now we do the equation of the tangent. So we substitute the x and the y of the point of contact. There they are. And you substitute the gradient, -7, multiply out all the brackets, and then you get the equation. Or you could have used y = mx plus c, substitute the y and the x, and the gradient, calculate C, and then you get your equation. Are there any questions?
No, I just wanted to ask, so then at the beginning, how did you know that the center of the circle is 0, 0?
Because there is no x minus something squared, y minus something squared. Let's look at example 2. Determine the equation of the tangent to this circle. Now we have x squared and y squared and more terms. So this tells me that this circle is not on the origin, it's off the origin. We also have a point of contact. Draw your circle, draw your picture. Okay. We don't have the center yet. The 4 steps are: first calculate your center of the circle, then calculate the radius gradient, then calculate the tangent gradient, and then use those two, the center and the tangent gradient, to get the equation. You all follow? Right, so we start with the given equation and complete the square. Remember, if you complete the square at the x's and at the y's, that you also need to add them on the other side of the equal sign. Then you get your equation. From this, you can read off the center. The center is Poppejane. So if that's a -1, the center is a 1. If that's a +1, this one is a -1. Now we have the center. Get the radius of the gradient's radius. So we use the center and the point of contact to calculate the radius gradient. It's -2/3. To get the tangent gradient, we have to tip and flip that one, so it's +3/2. The reason? Radius perpendicular on tangent. Now you use this tangent gradient and the center of the circle and substitute that into your formula for the straight line, and then you get that. Or you use the other formula of the straight line, calculate C, and then you get the equation. You all follow. It's very easy, but it's long calculations.
When you said you knew it was off the origin because it had a lot of terms.
Yes. If it only has 2 terms like this one, x squared plus y squared equals 50. So there are only 2 terms. Then you know it's at the origin. But if it has the middle term of a trinomial, like that, x squared plus 2x, and then it meets the third term, and y squared plus 2y, and we need the third term. Then you complete the square, and then you know it's not on the center, not on the origin. Okay. More questions? All happy? Homework is exercise 4. Page 19, number 1 to 5. And if you are done, you can start with the exam questions, number 1 to 4. And then tomorrow and on Monday we'll mark everything, and then we are done with analytical.